right? So that, what does this means? This means ki we cannot have a more flux from the machine, right? We cannot have more flux in the machine by giving it the more field current, right? So that leads your motor into the saturation region. So to avoid all these things which leads to your motor into saturation region, and consequences of which will be the higher losses, high acoustic noise, higher your higher core loss, right? So in place of those, or to avoid those, basically we don't want your motor to go into the saturation. So for this, what is being done, as we have studied in case of induction motors, what we do is we take your motor into your, we take this drive into triple VF mode. What is this triple VF mode is? Basically, triple VF means variable voltage, variable frequency. Ki along with the variation in the frequency, we do variation in the voltage such that your flux remains constant, right? So we do so to keep the ratio of V by F constant, right? And we do so only in the region below to the rated speed. After a rated speed or beyond to the rated speed, what we do, we only alter this frequency, right? We only increase the frequency, we do not increase this voltage after the rated one. But we, in the case of decrement in the frequency to decrease the speed, we also decrease the voltage such that this V by F ratio can be kept constant. So this is the basic structural strategy that is being used to have the synchronous motor drive. Now what is being mentioned in the book is that there are two modes in which this triple variable frequency control can be basically exercised, or can be done. And what are those modes? They have mentioned that they are the two modes of operation. We can call them as modes of operation for variable frequency drive. What are those modes? One is the true synchronous mode. One is the true synchronous mode, right? And other is self control mode. Self control mode. So these are the two modes. In the true synchronous mode, what is being there is, in both the cases, basically what we'll be doing, we will be varying the frequency. But in the case of true synchronous mode, your frequency is independently varied irrespective to the motor or rotor speed, right? What we do, we pass on the variable frequency from an independent source. Whereas in case of self control mode, there this frequency is varied, keeping a eye or control over the rotor speed. So in case of self control, by in both the cases, see, we want our synchronous speed to be increased or decreased by increasing or decreasing the frequency, no doubt over this. But we also know that your motor can only run at this speed. If somehow your synchronous is being your synchronous is being loosed, then your motor will get stopped, right? So we had to vary the frequency very gradually, very slowly, such that the synchronism of the rotor does not get out, right? We do not lose the synchronism. So in the true synchronous mode, your there is no knowledge of rotor speed is being there, right? And we independently increase the frequency without keeping the eye over the ns, right? What the actual rotor speed is. So we gradually increase the frequency. Whereas in the self control mode, we also keep an eye on the rotor speed along with the variation in the frequency. If suppose we are increasing the frequency, so we does not keep continuously keep on increasing the frequency, or you can say that the rate by which we increase or decrease the frequency in self control mode, we have a control over that, right? In this true synchronous mode, the rate at which frequency will be varied, it is being fixed, right? Is this clear? Is this clear?
Yes, sir.
And hopefully I have make one schematic for you for the variable speed drive. Suppose we are having a synchronous motor. This is the synchronous motor whose speed we want to control. So we can do it by the help of, suppose we are having an AC supply. So instead of giving this AC supply, and suppose we are using a voltage source inverter, so obviously this AC supply needs to be rectified to given to this voltage source inverter. So it is being mentioned in the book that this AC supply which is available to us is first rectified through a rectifier, and then passing the output of this filter, passing this output through a filter, LC filter, is being given or feed it to the inverter, right? To make a to have a control over this, V by F control strategy can be used, where we can give a frequency, desired frequency as an input, and accordingly the frequency of this VSI inverter can be controlled. Now this is the control over the frequency, but we know that we had to keep this V by F ratio constant. So along with the frequency, or in proportionate amount to the frequency, your voltage is also varied, right? And it is varying with the same rate, that it will be varied up to the rated speed, and after that V will be kept constant, will not going to increase this. So V star is being basically generated from this lookup table, right? And we call it as flux control. Flux control generally being done by lookup table. So with the help of this V star, one alpha, this alpha means the firing angle of this rectifier is controlled such that we can have a control over this VDC, right? We can have the control over the voltage generated to the given to the synchronous motor. So this is the basic schematic of variable frequency control. This is a schematic for variable frequency control of synchronous motor, of synchronous motor, right? I guess now it's being clear to you ki how can we have a speed control of synchronous motor, right? Now let us move towards the permanent magnet synchronous motor. So we have learned that your permanent magnet synchronous motors are of two types, right? They are of two types based upon the kind of rotor they use, right? Based upon the rotor geometry, they are of two types. कौन कौन से थे बता सकते हैं?
Surface mounted and interior.
Very good. That is the surface mounted and interior type, right? In the surface mounted, what was there is ki rotor structure. What we do is we paste the permanent magnets over the surface of the rotor structure, right? If these are the magnets, so magnets are being pasted over the surface, right? Your magnets are being pasted over the surface, and we call them as surface mounted permanent magnet synchronous motor. This is the rotor structure, right? And these are the permanent magnets. Whereas in the interior type, the permanent magnets are inserted or buried into the slots in the rotor structure like this way. Okay. So we have two kind of permanent magnet synchronous motors based upon the rotor structure, right? But based upon the voltage induced, in the rotor windings, in the stator windings, these motors can be classified into two categories, right? Permanent magnet synchronous motor. I am talking about permanent magnet synchronous motor. These permanent magnet synchronous motors based upon the induced EMF on the stator, right? They can be classified into two categories. One is called as sinusoidal, right? PMSM. In fact, more commonly, this PMSM word is more commonly called as PMAC, right? Permanent magnet AC motor. So its general word PMAC. So we can call it as sinusoidal PMAC or PMSM, right? Whereas other one is trapezoidal, that is trape, trapezoidal PMAC. Difference is what? The difference will be only in the wave shape of the generated or induced EMF, right? When we'll supply, don't forget that both the machines, whether it's a sinusoidal PMSC or a trapezoidal PMSC, both will be having the three-phase windings, right? That will be fed through the three-phase supply. But there will be a difference in the generated EMF wave shapes, right? One will have a sinusoidal and other will have a trapezoidal. Now, if you see or when you'll read the book, you will find that it is being mentioned this that the trapezoidal PMAC, the trapezoidal PMAC, that is permanent magnet AC motor, are nowadays are nowadays commonly called as what we call them as, Sunil?
सर BLDC motor.
Right. We commonly call them as BLDC motors. That is brushless DC motors. Right. So I hope now you could have understood that why in the unit 4 the synchronous motor drives are kept, or BLDC motor drives are kept with the synchronous motor drive, as your BLDC motors are nothing but they are also a kind of permanent magnet or a synchronous motor. In fact, basically they are a kind of synchronous motors, right? Now, before we move further or before we discuss further, let me can we answer this question at this stage? That why we call them as brushless DC motors? Well, although it's a kind of synchronous motor, so why name is being given as BLDC motor? Can you comment upon this? Can you have some?
सर परमानेंट मैग्नेट स्टेशनरी होते तो उसके लिए ब्रश असेंबली नहीं अच्छी होती.
सर डीसी सप्लाई देते हैं, उसको इन्वर्ट करके फिर एसी बनाते हैं, बट जो इनिशियल सप्लाई है वो डीसी रहती है.
वेरी गुड,
तो इसलिए ब्रशलेस डीसी होता
वेरी गुड, वेरी गुड.
है. सर स्ट्रक्चर भी डीसी का तरह ही होता है, बस जो कम्यूटेशन होता है वो इसमें इलेक्ट्रिकल हो जाता है और ब्लड इसमें नॉर्मल डीसी मोटर में मैकेनिकल होता है.
ठीक है, ठीक है, वेरी गुड. बेसिकली अगर आप गौर देंगे सबके सब जो मुझे सुन रहे हैं, तो वो देखेंगे कि जो सिंक्रोनस मोटर है वो डबली एक्साइटेड मशीन है, राइट? सिंक्रोनस मोटर इज अ डबली एक्साइटेड मशीन, यस और नो? बोलो जरा, अरे हाँ ना तो बोलो.
यस.
सिंक्रोनस मोटर इज अ डबली एक्साइटेड मशीन, राइट? और डबली में भी इट ऑल्सो रिक्वायर एसी एंड एज वेल एज इट ऑल्सो रिक्वायर डीसी, राइट? एसी सप्लाई भी चाहिए और डीसी सप्लाई भी चाहिए. डीसी सप्लाई कहाँ चाहिए? रोटर पर, टू क्रिएट द फील्ड्स. और यू कैन राइट इट लाइक दिस कि वी रिक्वायर डीसी सप्लाई फॉर फील्ड जनरेशन, whereas AC supply is required to be applied for stator winding, right? We require DC supply for rotor, ऐसे समझो. We require DC supply for rotor, whereas we require AC supply for stator. In case of permanent magnet synchronous motor, there will not be a requirement of DC supply. This is very fine, right? We don't require this one because already we are using the permanent magnets and that will be generating the fields, right? That will be generating the field flux, right? But what happens with the stator supply? In case of trapezoidal PMAC machine, that is the BLDC motor, instead of supplying it with the AC supply, although it requires AC supply, what is being done? Arrangement is being made that you will feed the DC supply to the motor, but in the motor there will be an integrated inverter circuit. So your inverter circuit will be an integral part of the BLDC motor, and that will be converting this DC supply into the AC. That's why it looks like that we are feeding your motor with the DC supply, right? Although there is a one inverter, and that is being converting this DC into AC for its stator supply, right? Is this clear? Why we call this as BLDC? So we are calling it at DC motor because we are feeding it with the DC supply. Why we are calling it brushless DC? Because no brushes are being used to invert the DC supply into the AC supply. We are using an power electronic inverter to convert this DC supply into the AC supply. That's why this motor is called as brushless DC motor. Is the thing clear to you?
Yes, sir.
किसी को समझ में आया? किसी को भी? कोई एक जिसकी बात ये समझ में आई हो?
Yes, sir.
है ना? तो that's why we call this as
Yes, sir.
BLDC motor, right? We'll discuss and we'll read about the BLDC motor in the next class. Okay, that's it for today. आज के लिए इतना ही छोड़ दें या बता दें थोड़ा BLDC के बारे में? बताओ.
ठीक है सर, आज के लिए सर टेस्ट थोड़ा पढ़ना भी है.